Okay, our deal we're going to do now is we're going to graph this polynomial function. We're going to show all the roots. We're going to find out a rough estimate of the max and min, and analyze the end behavior. Okay, sounds like a ton of fun. Okay, first thing we're going to do is realize the only way to factor this would be to use something called rational roots theorem. Okay, so we're going to do that. We're going to take all our factors of p and q, and right now 40. So we're going to use, let's do an order. Let's say we have a 1, we have a 2, sorry about that, we have a 2, we have a 4, what do we have, a 5, we have an 8, blah, 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 blah. We don't need it all right now because I made this out pretty nice. This is all over my factors and my leading coefficient, 1, okay? So we have a 1 over 1 plus or minus, so plus or minus 1, 2 over 1 plus or minus, you get the idea? 4 over 1 plus or minus. And we keep going, and again, these are like our keys that allow us to find out how to break into this function. I could try a 1 and find out it doesn't work. I actually made this myself, so we're going to use a 2, okay? So let's say we have a 1, and we use synthetic. We have a 1, we have a 3, we have a negative 18, we have a negative 4. If I want to break into it with, let's just try a 2 and see what happens. If we try a 2, then I go in. I get a 1, I get a 2, I get a 5, I get a 10, I get a negative 8, I have a negative 16. Didn't work, right? So instead of a 2, we'll try a negative 2. Let's see if this works. We get a negative 2. We get a 1. We get a negative 2. We get a negative 20. We get a positive 40. And we get a 0. That's just what we wanted, right? So we get a 1, a 1, a negative 20. We start with an x cubed, so we realize this is going to be an x squared. If that's an x squared, this is an x, and we're good to go. We're going to factor this one more time, okay? We're just going to use our magic number trick here. We know x, leading coefficient of 1, product is negative 20. I'm thinking it's going to be a 5 and a 4, right? So we get a 5, and we get a 4. If it's a negative 20 but a positive 1, it must have been plus here and minus here, right? 5 take away 4 is 1. Negative 20. So we know immediately I have 3 possible real roots here. We're going to do a negative 5 for a root. We are going to do a positive 4 for a root. And we're going to use a negative 2 for a root. Does that make sense? That doesn't look like a 2. Does that make sense? So I got all that? Okay. So right now we are going to sketch out a quick graph. Say we have something like that. Say we have something like that. Grab a different color here. Let's use pink. There we go. Okay, so at negative 5, 1, 2, 3, 4, 5. There's a root. At 4, 1, 2, 3, 4. There's a root. At negative 2, there's a root. Okay? What we're going to do now is analyze our end behavior. We have an odd, we have a positive. So we know our end behaviors. Let's see here. Kind of look like that, right? Now I don't know exactly where this rises and falls, but hold on. I think I have a third color. We know approximately, give or take, it looks something like that. We're going to do all the information out to find out really close where it is, okay? So let's say we're looking here. Why don't we plug in an example of a 2? This is just going to be rough here, right? So if we plugged in a 2 to this original, okay? Let's say we did a 2. We did it before, but I forgot what it was, to be honest. So when I dropped it down, I get 1. I get 2. If that's a positive 2, I get a 5. Right there, right? I get a 10. Still get a 10. I get a negative 8. If I get a negative 16, what do I get? Negative 56? Yep. So negative 56 it would be. Okay, so that's obviously a big number. Why don't we start with negative 10? Let's say that's negative 50. And let's say at 2, we are roughly down to negative 56. Let's call that kind of an approximate min. Okay? Min at 2, and it's approximately negative 56. That is good to know. So I'm going to kind of go like this now. A little bit rough, but not too bad. We know immediately at negative 40 is our y-intercept. 0, 0, 0, negative 40. So right about here. Again, this is approximate. Without calculus or a graphing calculator, that's all we're hoping for is approximations right now, okay? So when I come over here, I took care of this. Now when I plug in a negative 3, we're going to get another idea. I'm running out of room here. Let's see here real quick. I don't know if that's going to work or not. Okay. When I plug in a negative 3, let's say it's a negative 3. I drop that. Okay, don't worry about that for a second. I drop that, and I get a 1. I get a negative 3. I get a 0. I get a 0. Right? So I get a negative 18. Is that negative, negative, positive? Is that 54? So I get 54 minus 40 is going to be 14, right? Okay, that's good to know. Remember we just did synthetic substitution. We plugged it in directly, so at negative 3, if that was 10 here, that's a negative 10. Let's say it's 20. So we're saying approximately negative 3 units, we're up at 14. So negative 3 units, let's say right about there. That makes sense? I'm also going to plug in a negative 4. Okay? Okay, I can do this here. Don't worry about that. Don't worry about that. Let's plug in a negative 4. At negative 4, I drop a 1. I get negative 4. If I take care of that negative 4, I get negative 1. Negative, negative, positive, what's that, 4 again? So if I get 4, it gives me a negative 14. What's that? Negative, negative, positive, 56. So if I get 56 here, what's that? Take away 40. That can be 16, right? So 16 at negative 4 units, we're at about 16. You know, I don't know exactly the answer, but I think we're pretty close. So we're going to say max at negative 4. Okay, I'm going to say approximately, we come up with positive 16. Approximately, right? Give or take, we're pretty good. So I'm going to take this, I'm going to sketch it out here. Sketch it out here. Remember, negative 40 was my y-intercept. We're looking pretty good. Max, min, and behaviors again, let's do it real quick. As my f of x approaches negative infinity, negative, my x is approaching negative also, right? So that's good to know. Negative, negative. As my f of x approaches positive infinity and beyond, right? My x's are also approaching positive. We are doing pretty good. If I were to throw in real quick in green my domain, we can see that all of our x's are included here. So we're going to say x is going to be all real numbers. And if I want to throw in my range real quick, we can say that my range, my y values, are also all real numbers. So this is not a bad little graph. I think we got everything we needed. Dun-da, dun-da, dun-da. Looks good. Okay, good job.